Welcome to Peniel Educate. In this video series, we'll be looking at algebra for basic 6. If you're in primary 6, these are the things you're expected to know before you go to the secondary school. So let us start with algebra, looking at the operations with brackets. Now, if you look at the line that is drawn, the diagram shows line A, is line A here, and we have D. So that diagram is divided into 3 parts. We have AB, we have A, we have B, okay, then we have C, then so we have a length BC, that's AD, this is AD, AD, and this AD we have AB plus BD, so it can be AB here plus BD here, makes the line AD. Now if the line AB is X centimeter, this is X centimeter here, all right, and we have line BC to be Y centimeter, then we have line CD to be Z centimeter. So we have line BD will be equal to Y centimeter plus Z centimeter, while we have AB will be equal to, is still X centimeter. So if you add the two lines together, we have X centimeter, okay, X centimeter plus Y centimeter, which is B C, okay, then plus CD, which is Z centimeter. Don't forget that BD, this line BD is actually BC plus CB. That is, BC is Y centimeter, and CD rather is BC plus CD. So CD is Z centimeter. So that's why we have line BD to be Y centimeter plus Z centimeter. All right. So when you have this, so we have X centimeter plus then BD, which is Y centimeter plus Z centimeter. Then if you open the brackets, we're going to have X, okay, plus Y plus Z, that's in centimeter. So if you open these brackets, you're going to have X plus Y plus Z. Now, you need to note something here, that a positive sign, okay, a positive sign before a bracket, okay, a positive sign, okay, positive sign before a bracket, maybe X plus Y, a positive sign before a bracket does not change the sign inside the bracket. It doesn't change the sign inside the bracket. So you're just going to have, if you open this bracket, you're going to have plus X, okay, then plus Y. So a positive sign before the bracket doesn't change the sign inside the bracket. All right, so that's one thing that I want you to take note there. Okay, now let's look at another one. We have a line AB, okay, this is AB. Now we have BC, this is BD, then we have DC. Now line AD, this is from here, this A here to here, this line AD, okay, is actually, this line AD is actually AB, okay, plus BD. Okay, so this line now, this is A, this is D. For you to find the line AD, you're going to have line AB, which is this line here, plus BD will give you line AD. All right, now if you calculate line BD, this line BD here, okay, if from BC, line BC is Y centimeter, so line BC is Y centimeter, then line BD is going to be the line BC is y centimeter, while we're given line DC to be z centimeter. All right, so for you to find this is what we're actually talking about. We have line B, we have line D, and we have line C. So this particular one from here to here is given as y centimeter. Then from here is given as z centimeter. So for you to find out here, so you just need to look at total here minus this. So here will be y minus z centimeter, which is BD. All right, so now you have your BD to be that. Don't forget you have your line AD is AB plus actually plus BD. So AB is given as x centimeter, you know that one already. Then we have BD, which is given as y minus z centimeter. Okay, so now let us do our calculation. X centimeter plus, don't forget this is y minus z centimeter. All right. Okay, so now once you expand it, it's going to give you x plus y, then minus z. Now, another thing that you need to take note here is that a positive sign before a bracket does not change the sign inside the bracket. Just don't forget that this one is minus. So once you expand it, this plus y, then this minus remain the same. A positive sign does not change the sign inside the bracket. That is, a positive sign before a bracket does not change the sign inside the bracket. So that's to reinforce the first learning on this. So a positive sign before a bracket does not change the sign inside the bracket. So you can have something like let's say 2, okay, plus 3, all right, into 5 minus 2. So 2 plus this 2 can be to represent x. All right, so this is plus, this is a positive, just this, so this is a positive 3. So once you do this, you do 3 times 5, you're going to have plus 15. Then this plus 3 times minus, you're going to have minus 6. So it doesn't change it. So what you don't need to do is 2 plus 15, which is 17, minus 6, which is going to give you 11. Okay, so and it's the same thing. If you just do 5 minus 2 here, this is 3. Okay, 3 multiplied by 3, that's 9. 9 plus 2 is the same thing as 11. All right, so that is what we're talking about. A positive sign before a bracket does not change the sign inside the bracket. It doesn't change it. Okay, so let's quickly move on to another one. Okay, now let's look at this. We are given a line now. So let us look at our line AD here. Our line AD here. This is our line AD, which is here. Now, if you want to find our line AD, which is from here to here, okay, we're going to have, from here to here, this is AB, okay? So, AB, our line AD from A to here, A to D will be AB, then minus DB, okay? Right, this place, right, this is D, this is DB, from here to here is DB, okay? And we have from here to here is AB. So for us to have our line AD here, which is this place, we must do AB minus DB, which is what we have gotten here. But we were actually given DC to be Z centimeter, and we have our CB to be Y centimeter. Okay, so line DC, rather line DB will be, line DB will be DC plus CB. Okay, line DB will be DC plus CB, and that's what we have here. And don't forget that we are giving DC to be Z centimeter. This is DC, and we have CB to be y centimeter. So this particular one is DB is y plus z centimeter. So we have our line AD, which is AB minus DB. So we have our x, which is AB. This A to B is x centimeter. So x minus y plus z, which is, line DB. Okay. Now, once you expand this, you discover that the sign inside this bracket has changed. So you have like x minus, y, then minus z. All right. The sign has changed. So now, what it means is that a negative sign before a bracket changes the signs inside the bracket. So a negative sign, before the bracket changes the sign inside the bracket. So to change, and that's what we have there. All right. Okay, so let's look at the last one in this operation of bracket, just to buttress what we have been talking about. All right, so if you look at this one also, we have our line AD, which is our line AD here. That is what we are looking at. So this is our line AD. For us to find line AD, we must subtract this line AB minus DB. AB minus DB will actually give us this. So for us to find out this line, this particular lines. So AB minus CB, that's what is going to minus AB minus DB. AB minus DB is going to give us our line AD. All right, so and we're given our line CB. This CB is from C to B here, is given as y centimeter, which is this. CB is y centimeter, and we're giving CD to be z centimeter. All right, so our line CB here, this from here to here, is actually CD plus DB. Okay, our line CB will be CD plus DB. Okay, so we already know that our line CB is y centimeter and our line CD is z centimeter. So we're to find this line DB. So if you do the arithmetic, you find out this is z centimeter. So if you want to find the DB, so y z centimeter will cross to this side. So definitely you have your line DB to be y minus z centimeter. That's why we get our line DB to be y minus z. Okay, so now we want to find our line AD, which is AB minus DB. Okay, so AB is x centimeter minus y minus z. Y minus z is the DB. All right, so when you look at this, you discover that immediately we open the bracket minus y, the sign inside the bracket changes to positive. So you're going to have x minus y plus z. Okay, so that is still buttressing the fact that a negative sign before a bracket changes the signs inside the bracket. Let me say it again. A negative sign before a bracket changes the sign inside the bracket, while you have a positive sign before a bracket does not change the sign inside the bracket at all. All right, so we'll look at examples. We'll look at examples of based on what we have been talking about since. All right, so we have this example: 4b plus 3 plus 5 minus 2b. Okay, so what do we have? We have 4b, okay, plus 3. So positive here, to expand this will be positive 5 minus, it won't change, positive sign before a bracket doesn't change anything inside the bracket. So plus 5 minus 2b. So you have bring the like times together, 4b minus 2b, then plus 3 plus 5 is going to have your 2b plus 8. We're given 3x plus 2y minus x minus 3y. Don't forget a negative sign before the bracket changes the sign inside the bracket. That's why you have 3x plus 2y, then minus here with minus x, minus multiplied by this go to what? Positive, then 3y. So 3x, try to collect the like times. 3x minus x, then plus 2y plus 3y is going to give you 2x plus 5y. All right, so look at other examples. All right, so we have 2 into 3x minus 1 minus 1 over 3 into 3x minus 9. Okay. All right, so if you do the multiplication here, this one will give you 2 times 3x, that is 6x. Then 2 multiplied by minus 2, minus 1, that's minus 2. Then minus, don't forget, this is minus 1 over 3. Okay, multiplied by this is going to give you a minus x. Okay, 3 would have cancelled this. Okay, so a minus 1 over 3 multiplied by a minus 9 is going to give you a positive 3. That's by minus 1 over 3 multiplied by the minus 9. So 3 will cancel 3. 3 here 1, 3 here 3. That's plus 3. And you're going to have collecting the like time 6x minus x, then minus 2 plus 3. Going to give you a 5x. If you do minus 2 plus 3 is going to give you a positive 1. Minus 2 plus 3 is a positive 1, and that is going to be the answer. All right, so but there are some things that I also need to let you know here in this particular algebra in arithmetic. A negative sign multiplied by a negative sign is going to give you a positive. All right, a positive sign multiplied by a positive sign is going to give you a positive. You need to note that. All right, now when you have the sign that is not equal, positive sign multiplied by a minus is going to give you a negative. A negative multiplied by a positive is going to give you a negative. All right, so you see that these two, they are equal. All right, so and you have a positive. Minus and minus is positive, plus and plus is positive. But when you have the sign differently, plus multiplied by minus, it's going to be minus. Minus multiplied by plus is going to be minus. Okay, for example, you have a minus 2 multiplied by a 3. This is like a positive. All right, so 2, this is going to give you what? A minus 6. That's what it's going to give you. That's a minus 6. So that's some things that you need to understand in the operation of brackets. Okay, and then another one that is also worthy of saying here is that in addition, these are just in addition, but these are just the multiplication. In addition, when you have a minus 2 in minus 3 is going to give you a minus 5. Okay, minus is going to be minus. Okay, a 6. Okay, maybe minus 15. So what we are saying is that a positive 6 minus 15, that's what it means. So this negative 15 is more than positive 6. So your answer is going to be a negative 9. All right, let's do it again. Let's do some other example. Okay, let's do some other example quickly. All right, so let me do further example. Okay, so let's have like let's say normally you have a 15, normal arithmetic, a 15 minus 5, you're going to say it's 10. But what it actually means is that a positive 15, that's what it means, a positive 15 minus 5. Okay, because this positive 15 is higher than a negative 5, and that's why you have a positive 10. All right, so if you have a 5 plus 5, it's as if you are adding a positive 5 plus another positive 5, you're going to have a positive 10. All right, so likewise, if you have a negative 7, or probably let's say let's even say something similar, a negative 5, then minus a negative 5. Also, you're going to have a negative 10, right? Minus 5 minus 5 is minus 10. Okay, plus 5 is positive 10. So either way, 15 minus 5, this is a positive 15 minus 5 is going to give you 10. So if you have a 5, okay, minus 15 is like a positive 5 minus 15 is going to give you a negative 10, because minus 15 is more than the positive 5. So that's going to give you a negative 10. So those are the things you also need to know while you work on algebra. Okay, so let us look at terms involving powers. So let us consider a square of side y centimeter as shown in the diagram. Consider a square of y centimeter. The area of the square is given as y multiplied by y, and that is y square centimeter square. So y squared is read as you call it y squared, okay? Or you say that y raised to power 2, okay? Y raised to power 2. That means you have two y's, y raised to power 2, y squared, or y raised to power 2. All right, so if we have a cube side, if you have a cube of side, let's say z centimeter of a cube, you know that the volume of a cube is z multiplied by z multiplied by z, centimeter cube. So the volume is z cube centimeter cube. So you read it as z cubed, or z, raised to power 3. Read it as z raised to power 3. So if you have 3 cubes, let's say we have 3 cubes. If you have 3 cubes, you're going to have z3 plus z3, okay, plus z3, because each volume is a z cube, centimeter cube. So you have 3z cube centimeter cube, or say 3z raised to power 3. 3z raised to power 3. Okay, so you can also have z raised to power 4, okay, centimeter cube. So you can have things that are raised to the power of 4, or other ones as the case may be. All right, so let's look at examples involving powers. Okay, we're given 4a b squared, so you already know what it is now, or 4ab raised to power 2, 4ab squared multiplied by ab squared. Okay, so once you do that, you know that this is 4. This is actually 4 multiplied by a multiplied by b squared. That's what it means. Then multiply by a multiplied by b squared. Ab squared is a multiplied by b squared. So if you look at it and you bring all the like terms together in multiplication, we have a multiplied by a, b squared multiplied by b squared. So now a multiplied by a, that is 2a, that's why it's a squared. Now this one is b squared, that's 2b. B squared means 2b, b times b. All right, so another b squared means b times b. All right, so if you have b squared multiplied by b squared, it's actually telling you that there are 4b. That's b raised to power 4, and that's why you have b raised to power 4 here, and you have this one as a squared. So our answer is 4a squared b raised to power 4. That is examples involving powers. All right, so we also look at addition and subtraction. Addition and subtraction of terms involving powers. We have 3a squared plus 4a squared minus 2a squared. All right, so in this you need to bring the ones that have the same metrics. You need to bring it together. For example, 3a squared and 4a squared and minus 2a squared, all these ones have the same. Now see, you are bringing people that have the same surname together. All right, so maybe this is a squared. This a squared means Philip. So you have 3, this a means apple. So we have 3 apples square. Okay, 4 apples square minus 2 apples square. So they are all family of square. Apple square, apple square. So if you bring this one together, 3a square plus 4a square, that is 7a square, maybe 7 apple square. Then 2a square, that maybe is about that's 2 apple square. So we have 7a square minus 2 apple a square. That's so you're going to have a 5 a square. All right. Now, when you now have this 2b cube plus 3b square plus b, these are not the same. All right. So you cannot add it because this is b. Okay, 2 ball cube plus 3 ball square. So they are not bearing the same thing. They are not having the same indices. This is b cube, this is b square, this is b, maybe raised to power 1, so that is b. So this b cube is not equal to b square and it's not equal to b. So this formula, this one remain the same. There's nothing you can do about this. Okay, so let's look at this. We have 6g square minus g square minus 4g square. These are similar. So 4g square minus g square is going to give you 5g square minus 4g square, and it's going to give you a g square. All right, that is terms involving addition and subtraction, um, involving okay, that's addition and subtraction of terms involving powers. All right, so let us look at factors in algebra. Okay, so and just similar to the other way of knowing factors. Okay, we have 3ab square a square b and 6ab square. How do you know the factors? We have 3 is a factor, a is a factor, another a, 2 is times b. We have 6ab square is a 2 multiplied by 3. You can do put this one in fact factorize this as 2 multiplied by 3 times a times b times b. All right, so that is so if you want to look at the common factor to them, so you know that 3 is common to this. Okay, we have a common to this, we have another b common to this, so you can have 3ab, okay, as a common factor for these two algebra. Okay, all right, and it's the same thing that we do when you are doing division or multiplication in algebra. You do the same way you do normal arithmetic. For example, this particular one is 6 multiplied by m multiplied by m multiplied by n, and this one is 8 multiplied by n. So n can cut this, 2 can go here 4 and 2 can go here 3. Okay, so we have 3mm, so that is 3m square over 4. Okay, that's 3m square over 4. All right, so the same thing goes with this. We have 4f and we have g4, that is about 1 2 3 4. Then 10 2f, okay, 3f's, that's 5 cubed. Then we have g squared, that is 2g. So we can have 2g, cancel 2g here. All right, we have 1f, cancel 1f here. 2 can go here 5 and 2 can go in 4 2. All right, so is there another thing that we can cut? Okay, nothing more. So we have 2 g multiplied by that's 2g squared, then 5 multiplied by f, that is f squared. So we have this. So this is our where we arrive at our answer once we are doing this simplification. All right, so if we quickly look at the terms involving square roots, for example, we're given area of a square to be 16 centimeter square. Then the square root will be what? You can square root of 16 is 4, but before you do that, you can do 4 multiplied by 4. Okay, and that's the square root. Then your square root will be 4 centimeters. So once you have a length that equal to this one, also you can do y multiplied by y, and once you do a square root, you need to choose one of it once they are equal. All right, that is how that one is. So if we look at this now, we have to simplify this. Okay, so we have 4 multiplied by 4, Okay, that is the 16, times m square multiplied by m square. Okay, that one also can go. Then we have n times n. Then the square root will be 4, which is 1, m square. Then n multiplied by m square. Okay, multiplied by n. That is putting everything in two places. Okay, so this is what we are still solving. All right, so and the square root will then be 4m square n. All right, normally the square root of 16 is 4. The square root of m4, if it's m4, m square times n square, and you do the square root, it's going to give you m square, right? The square root of n square, okay, it's going to give you n multiplied by n, that is n. All right, so that's why you have 4m square n. So that is how to simplify that. Okay, so if we look at further algebraic fractions, you will see that okay, in this particular expression that is given, you have 3x over 4 plus 5x over 8, and the SCM of 4 and 8 is just 8. Okay, so you already know that one, how to find the SCM. So 4 8 divided by 4 is going to give you 2, and you multiply this 2 by this, that's 6x, normal fraction. 8 divided by 8, this 8 divided by 8, that's 1. 1 multiplied by this 5x give you this, so it's going to give you 6x plus 5x is going to give you 11x over 8. So that's your answer, 11x, okay, over 8. Now let's look at this particular one. We're given 7. Okay, we're given 7. We have 9b, okay, minus 5 into 12b. Okay, now what is, if you look at the factor, this is 9b and this is 12b. Okay, so you can use 3b to divide it. All right, so you can use 3b to divide this. This will give you a 3. Okay, going to give you 3, and this one going to give you a 4. Okay, so you can also use 3. 3 can go here 1. Okay, 3 doesn't go here. Okay, fine. Then you can use a 4 also to divide this 1. So all the factors that are common to the two of them, so 3b, okay, which is there, multiplied by 3, multiplied by 4 is going to give you a 36b. All right, so 36b is your LCM. All right, so 9b from here is going to give you a 4. Okay, a 4 multiplied by, that's why you are doing a 36b, okay, divided by 9b. Okay, here, cancel here, this was going to give you a 4. So 4 multiplied by 7 is going to give you 28. Okay, that's going to give you a 28. Okay, so that's going to give you 28. So what about this other one? That's 36b, okay, divided by 12b. Okay, this is going to be 12 here, this 1, this 12 here, 3. So it's going to be a 3. A 3 multiplied by 5 is going to give you 15. So 28 minus 15 is going to give you 13. So your answer is actually 13 over 36b. Okay, so that is what that one is all about. Okay, so let us look take some other examples of other equations. Now we're given a 3b, so a 3 into this, or I said is greater than 5. 3 dash what greater, or maybe 3x greater than 5. You can be given any of such. So let's say, for example, you are given this minus 4 over 5 is equal to 1 over 5. You can represent this by x, you can represent it by anything. Okay, if this one is represented by x, then what you need to do is x minus 4 over 5 is equal to 1 over 5. So if you take everything here to the other side, because this one is negative, it's going to, once you cross the equality sign, it's going to change to positive 4 over 5. Then you can then do your normal arithmetic, find your SCM. This is 5, this is 1. 1 plus 4, 5 in here, that's 1. And 1 times 4, that's 4. 1 plus 4 over 5, which is going to give you a 1. All right, so also you can have things like this: 7c minus 8 is equal to 13, and the 7c minus 8 is equal to 13, and you have to find a c. All right, so I can also do something. Let me add plus 8 to each side to each side of the equation, each side of the equation. Okay, so if I had plus 8, I'm going to have 7c minus 8 plus 8, and I'm going to add 8 also to this side. So this minus 8 plus 8 cancel, that is zeros. I have 7c. This one is 21. Okay, so I can also say that, okay, I want to divide both sides, divide both sides with 7. All right, so I can do 7c, okay, over 7. Okay, can do that. 7c. Let me just take it up a little bit. Okay, all right, so I have 7c, over 7 equal to 21 over 7. Okay, because I'm dividing both sides by 7. So 7 cancels 7 here, 7 here 1, 7 here 3. So my C is actually 3. Okay, the same thing goes there. I can do the same thing. What I want to do is what? This is 3x minus 13 plus 26. 3x minus 13 plus 26. Sorry, is equal to 26 rather. So I can add 13 to both sides. Okay, 3x minus 13 plus 13. Then 26 plus 13. So what I'm just trying to do is for me to eliminate this particular one. So I'm going to have 3x, this is 0. Then I'm going to have 26 plus 13, that is 39. All right, so I'm going to divide both sides also. I'm going to divide both sides by 3. Can divide it by 3. Okay, so once I divide both sides by 3, definitely I'm going to have 3x over 3, and I'm going to have 39 over 3. All right, so 3 will cancel 3, 3 here 1, and 3 here 13. So my x will be 13. All right, so let us also look at further examples. This one is an example that is involving equations in decimal. So if we have things in decimal, for example, you have 6a is equal to 17.4. You can also do what? Divide, can divide both sides, divide both sides by 6. Okay, so 6 here, 6. So you can then do your normal arithmetic. If you divide this, that's going to give you a 2. It's going to give you a 2.9. So 6 here, that's 2. If you carry that one, that's 12. So you have 54. That's 2.9. All right. So so if you want to confirm 6a, if it's equal to 20.4, you can actually put it in the equation. This is 6. This is a. All right. Okay. So 6 multiplied by this is going to give you 7.4. This is just to confirm your answer. All right. So let's look at other examples involving fractions. Have 0.1y plus 2.7 is equal to y. Okay, so what we need to do first is to collect the like terms. Okay, so we have 2.7 here, so I can once I move 0.1y to this other side, don't forget that this is actually positive. So once it crosses the equality sign, it changes to minus. All right, so I have y minus 0.1, and what I'm going to have is 0.9y. So what I just have is as if I'm doing 1y minus 0.1y. Okay, so if you look at it, 1 minus 0.1 is actually 0.9. Then you put your y, because that's 0.9y. Then you can divide both sides by 0.9. So which divide both sides by 0.9 is going to give you a y. And if you divide this, you're going to have a 3. And another way you can do it is that you can do this 2.7, you multiply this one by 10. This 0.9, if you multiply it by 10, this has not changed because you did the same thing up and down. This multiplied by 10, this also multiplied by 10, and this one is going to give you 27 over 9, and it's going to give you a 3. All right, let me look at further examples. Let me look at further examples of this particular one. All right, so let us look at further examples involving fractions. Okay. All right, so we're given this particular example. So we know that the SCM for all of this equation is actually the SCM is 5k. All right, so what we then need to do is to multiply all of this fraction with 5k. So if I multiply this times 5k, all right, k will cancel here. I'm going to have a 30. Okay, if I multiply this one by 5k, I'm going to have k cancel this one, I'm going to have minus 20. All right, equal to, if I have this one multiplied by 5k, I'm going to have 5 here, 5 here, I'm going to have a 3k, then minus, if I want this one multiplied by 5k, I'm going to have k here, k here, to have minus 15. So I'm going to have 10 here, 30 minus 20 is 10, which is equal to 3k minus 15. Okay, so if I, add, 15 to both sides, okay, we have 15 to both sides, that will be 10 plus 15, and I'm going to have 3k minus 15 plus 15. So this is going to give me 0, this is going to give me 25, which is equal to 3k. Then my k, if I divide both sides by 3, I'm going to have my k to be 25 all over 3. And that is what my answer will be. All right, do you like this video? Why not give it a thumbs up, subscribe to our channel, and feel free to share with your friends and loved ones. I'm going to complete this video in the next video series, and this is just the part 1 for the algebra for basic 6. So in the next video, I'm going to start with applications of equations, and we're going to be looking at using equations to solve word problems. We're going to be looking at using equations to solve word problems. We're going to be looking at simultaneous linear equation in two unknowns. We'll be looking at how we can use elimination method. We'll be looking at how we can use substitution method, and we'll be doing some little things on quantitative reasoning. All right, so please subscribe to this video and share with your friends. All right, so see you in part 2 next week. Bye.